All right, integrated 2, we are in week 6. We're going to graph quadratic equations in Vertex form, okay? Week 6 is April 27th to May 1st. I know some of you guys, well, first of all, I appreciate those of you who are keeping up. I'm going to send an email out to everybody saying that, if I haven't heard from you in those first few weeks, if I can connect with you, I would like you to group weeks 3 and 4 together, okay? And then weeks 5 and 6. So for some reason, I haven't heard from you in a while. I don't want you to think that you've got to go all the way back and make up some stuff. In order to graph weeks 5 and week 6, to graph successfully, I'd really like you to have the background in week 4. But if I haven't seen you in a while or you haven't been in contact, I'm going to ask you to go back to week 5 and at least try and explore the graphing with me. And it's something that you can really pick up and do, because week 6 won't make some sense right here as we start today. Those of you who worked through week 5 and are about to see week 6, this is about to maybe get a whole lot easier for you, or let's just say a little bit different. I'm glad the videos are helping. I asked a few of you, are the videos working? And you guys are saying yes, it's just like being in class. And so anybody watching this, if you're saying you are stuck, I am maybe assuming that if you were a good student in here, that you are not watching the videos. And the people that are having the most success are the ones that are taking notes with me, pausing the video and looking at it. All right, you might remember this from week 5, okay? We said that instead of plugging in, we could come up with a system. So instead of plugging in your x's and doing the order of operations in standard form, that we could find a shortcut that worked all the time. So I want to remind you about this concept of 13. Okay, here's our parent graph, and here's its downside. If you look over here, here's y equals x squared and y equals negative x squared. So when we're saying when when a equals 1, we're just kind of here and we're here. Okay? And so last week, those of you who did the assignment know that if a was 1, and then if a was 2, it looks like we basically multiplied 2 times 1 and 2 times 6, or we double it, and now we go up 2, up 6, and sorry about that. And then we have symmetry, so it's 2 8 and it's 2 8. It's negative 2, negative 8, negative 2, negative 8. And if a equals 3, then we're going 1 times 3 is 3, and 9, up 3, up 9. Now I threw a problem at you, and that's of course I wanted you guys to be working on the Desmos. I threw a problem at you, I think it was the last problem, problem 10, where we threw in this half. Y equals 1/2 x squared. And so I looked at the assignments that you guys gave, and a lot of you guys were maybe kind of able to figure it out without me saying anything. You used the Desmos, but let's see if this makes sense. If a equals 1 is 13, and we double if it's a equals 2, then if we cut 1 in half, it's 0.5, and we cut 3 in half, it's 1.5. Or remember, substitute in. 1 squared is 1, 1/2 times 1 is 0.5. 2 squared, 2 squared is 4, half of 4 is 2. Okay? So, if we plot these graphs, then you can see here's our parent graph in blue, if a equals 1 and a equals negative 1/2. Now, if y equals half squared, remember when a was 2 and 3, we were getting narrow. But if we have a fraction between negative 1 and 1, notice it's going to get wider. Because remember, if you plug in for x, whatever you get, you multiply by 3. So the y's are growing faster, that's going to make you go steep. If you plug in for x, and then you're cutting it in half from here, your y's are going to slow down, and as your x's grow, it's going to get a little bit wider. So any fraction, whether it be a positive 1/2, negative 1/2, positive 1/4, negative 1/4, 2/3, or whatever you're going to see, possibly an IM3, then you want to kind of have the idea. Your teachers in IM3 will talk about vertical stretches, compressions, horizontal compressions, all these different things related to this right here. Okay? And we're going to see in vertex form that we actually have, if we understand this, and you understand vertex form, you're going to be able to graph even a little bit faster than we did with standard form. And like I said, your work with the standard form was really, really good for those of you who did it. So before we started, before I gave you the first example here, I wanted to give you our tables again so you have them in the videos. And I wanted to kind of throw in this 1/2 table. And I want to talk about this right here. Notice that x equals 3. And if you plug in here, you get 3 squared is 9, and half of 9 is 4.5. And so I know we usually do 5 points, 1, 2, 3, 4, 5, but if it's not enough, you can actually get more values. Remember, you can always plug in x's and solve for y. All right, so there's just a little bit more thrown in, and I want to give you a piece of that. I'm going to swing you guys around, and we're going to finish the rest of part 1 right now. So hold on. Close your eyes, as I always say. All right. So last week, we graphed in standard form. This week, you're going to see vertex form. So standard form is y equals ax squared plus bx plus c. You guys have factored it, you have solved it, you have done the quadratic formula with it, and you have graphed it. Okay? This problem and this problem are the exact same one. Now I know you see the letters different. If we were together, if we didn't have all this stuff going on with the COVID virus, we would actually have taught you and shown you how you go from standard form to vertex form. Now I'm going to make that a special lesson. So those of you who are looking forward to honors, or those of you who really love the math, those of you who are just looking at that A, I'm going to do a few bonus lessons to show you some things that you're going to want to know for next year. But we're just going to pretend it happened. So to go from standard form to vertex form, we're going to do something called complete the square. Okay? And that will be the bonus lesson, but I know your IM3 teachers are going to show you to you next year. And it's a bunch of steps, and there's a technique involved, but it's not impossible to learn how to complete the square. Okay. So what I'm going to do before we go here is I'm going to do what we did last week, but I'm going to take some shortcuts. So last week, I asked you to find the axis symmetry. So step 1 was A, B, and C. Step 2 was whether it goes up or down. So let's take the shortcut. So the axis of symmetry was x equals negative b over 2a. We plug in our b value and our a value, and after we do our order of operations and watch our signs, we get 3. We get an axis of symmetry of x equals 3. And I had you guys come over to your graph. And you made your axis of symmetry. Okay? Step 4, we found the vertex. We want to find our x comma y. We want to find our point that is on the graph. I know I got a parabola like this. I just don't know where it is. So we plug 3 into the problem. And if you do your order of operations, you punch in the calculator, we got -1. And we said our vertex was 3, -1. 3, -1. So those of you who have not watched week 5 videos, you might have no understanding what that is all. That's why you need to go back and do week 5 and then get caught up with me on week 6. But the next thing we did was we made a table. So we had 3, -1, which is right there. And then we did a point here and a point here. So we have 4 and 2. And we have 1 and 5. Okay. So A is 1, so if you go to your table, we go up 1, so that's 0, and this is 0, and next we go 3, okay? So it's our 13, and so we have 1, 3, and 5, 3. So last week you plotted your 5 points and you have your graph, and we could do that right now, but we're going to take a time out, okay? We're going to go backwards a little bit, and so we're going to take this problem here, x squared minus 6x plus 8. We're going to pretend that we completed the square together, okay, and we're going to turn it into vertex form. And this is what we would get. Now, vertex form actually means vertex. We're going to find our vertex right here, okay? Now, notice there is no A value right here, okay? So if there's no A value, of course, it's skinny friend. And this represents our x value of our vertex, and this represents our y value, okay? But there's one little thing here that you need to pay attention to. So watch this right here. If we match this right up with each other, okay, there's a negative and negative imperfect match. Notice what's going to happen. Our vertex, and sorry guys, I'm going to erase this. I hope you didn't write it down. Our vertex is h, k. Sorry about that. So your vertex is h, k. So it looks like your h value is -3, but it's not. This minus really does some stuff to it. So what's the opposite of negative h? Positive h. And if you do the opposite of one side, you do the opposite of the other. And you get h equals 3. So the question you're going to have for me is, well, Mr. Martin, does that all mean I have to do? And I just have to do the opposite? So if that's -3, then I know my h value is 3? Absolutely. Okay, and this is the reason why. So that's always the opposite. Notice, however, your k is positive. So positive k is the same as negative 1. So whatever this value is, because of the positive, that's your value. So your h is 3, and your k is negative 1. Your vertex is 3 comma negative 1. And better yet, I'll put it in black. Look familiar? Okay. So if a problem's giving you into vertex form, this is all out. All you have to do is grab the two values. Well, there's three things you need to do. I grab my vertex, and I grade my a value to know what my other points are. Remember, you can plug all these in and solve for y. You can do order of operations and solve for y. But isn't it a lot easier to read your a value? You go opposite to get your h value. Your k value is here. You get your vertex, and now we're still playing the same 13, 26, 39. Now we go back to our table, so we don't have to substitute in. Okay? Remember, this is a shortcut, so we don't have to do substitution followed by order of operations and take a chance at making mistakes or punching it all into our calculator at the same time. Okay? So complete the square is what puts us in vertex form. But what's going to happen in your IM3 is, here's how I am. If it's in standard form and I'm asked to graph, this doesn't take too long. If it's in vertex form, awesome. I'm going to be able to get my work a little bit sooner. But what you're going to be asked to do just for practice next year is you're going to be asked to work on just practicing how to complete the square. Okay? And so your teacher may ask you to complete the square and then graph in vertex form. So you kind of want to have a whole picture of it. What I'm going to do for this assignment, and what we're going to do in part 2 of the video, is I'm going to give you 4 problems in vertex form. We're going to put them all on one big graph, and then you're going to get your assignment. I think I'm going to give you 8 graphs total, 4 for Monday through Wednesday, 4 for Thursday through Friday. They won't take long to do. You'll be able to put 4 graphs, all 4 problems all on one graph. Do that twice. And that is going to be our set of problems for the week, except for the bonus lessons that I'm going to teach on quadratic formula. And either this week or next week, I'm going to do completing the square. Okay? So this is week 6. This is the end of part 1. And I'll see you in part 2. See ya.